In this video, I'm going to talk about one of the fundamental ideas of chemistry. It is the idea of the atomic structure or the structure of the atom. It's important just to remember that the atom, if we have the same type of atom, then we have elements. And that's where the term the periodic table of elements is coming from. So on the periodic table of the elements, we've got atoms which are the same, which make up that element. But I just want to talk about the structure of these atoms. And one of the first questions I'm going to ask is, what is the charge on a proton, a neutron, and an electron? And the answer is that these are relative charges that we're going to be talking about. And I'll explain a little bit what I mean by relative charge. So the relative charge on the proton is +1, the relative charge on the electron is -1, and the neutron is neutral. Now, they are relative because the actual charge on the proton is +1.60217657 times 10 to the power -19, and that's not even including all of the numbers that come after the decimal. And for the electron, it will be -1.60217657 times 10 to the power -19. So you can see that these are very small values, but they are exactly the same in magnitude. So it's exactly the same number, but the proton is positive and the electron is negative. So if we divide these two together, and because they're exactly the same number, we get a 1. Okay, so if we divide the proton with the proton, then we get a +1. We divide the electron divided by the proton, then we get a -1, because the negative carries weight in mathematical terms. But in fact, what we're trying to show is that we can compare two things which are the same and call them one, instead of calling them by their full numerical number, which is some decimal places, a lot of decimal places after the decimal, and also it's 10 to the power -19, which is quite a small figure. So we can safely say that the proton is +1 and the electron is -1. Now the neutron is neutral, which means the neutron carries no charge. Okay, and so where are they situated? These three particles. So these three particles, two of them are situated inside what we call the nucleus, and the nucleus is in the center of this atom. So the proton and the neutron are situated inside of the nucleus, and outside of the nucleus, then we have the electrons. The electrons actually occupy a very large volume in terms of the total size of the atom. So the electrons occupy a very large volume, and they are on the outside of the nucleus, and the nucleus, which carries a lot of the mass of the atom, is very tiny. So you've got a very tiny but dense nucleus which carries much of the weight or the mass of the atom, and the electrons, which have very little mass, occupy a very large volume. Okay, so this is how these three particles are arranged in actual. And to make a comparison, if you imagine that the center of a football pitch is the nucleus, well, if we place a football in the center of the pitch, then that football would represent the nucleus, and the rest of the pitch would actually represent the rest of the atom, or where the electrons are situated in this case. And what is there are two terms that we use to describe some of the numbers of particles, or these particles in the atom, and we call this two the atomic number and also the mass number. So what is the atomic number? The atomic number is basically the number of electrons that the atom has, and the mass number is the number of protons and neutrons which are inside the nucleus. So the number of protons and neutrons make up the mass number, and the number of electrons on the outside also make up the atomic number. But the interesting thing is that the atomic number, which is the number of electrons, is also equal to the number of protons, which are inside of the nucleus. Okay, so if an atom has, say, 5 electrons, then it also have 5 protons. But it may not necessarily have 5 neutrons. So it might have 5, it might have more. So it might have 6, 7. And the same element might have different numbers of, might have what we call isotopes. And these would have different numbers of neutrons, which would change the mass number but maintain the atomic number or the number of electrons. And so this is how the particles are charged, and also how they are arranged inside of the nucleus, and also their relative numbers, that is the mass number and the atomic number. And the last question I want to answer is, how are atoms arranged in the periodic table? And the answer is that they are arranged in terms of their atomic number. So remember that the atomic number is the number of electrons. And so if an atom is 1 electron, it's going to be the first one in the periodic table. And this atom happens to be hydrogen. So hydrogen is the first atom in the periodic table because it has atomic number 1. And the next element, or the next atom in the periodic table, is helium, followed by lithium, and followed by beryllium, and so on and so on. So helium has 2, lithium 3, beryllium 4. So the atomic number is rising as you move from left to right of the periodic table. And by the time you get to atomic number 103 or 104 or 7, I think there's about 110 by now, because we continue to discover new elements experimentally, that is. And so this wraps up what the atomic structure is all about. So one, the atom is made up of protons, neutrons, and electrons. Protons positively charged, electrons negatively charged, neutrons are neutral or have 0 charge. The electrons are situated outside of the nucleus in orbits, and the protons and neutrons are situated inside of the nucleus. The nucleus carries much of the weight of the atom, but it is also very small, and the electrons occupy a very large volume of the atom. Okay, but they also carry the least mass of the entire structure. The atomic number is just the number of electrons, which is also equal to the number of protons in that atom, and the mass number is the number of both protons and neutrons inside of the nucleus. And the arrangement of atoms on the periodic table is based on its atomic number. So atomic number 1, which is hydrogen, is the very first element, and then you get atomic number 2, 3, 4, which is helium, beryllium, boron, and so on and so on, and lithium as well.